LISP IPv4 unicast routing. In this video, I am going to show you how we can configure LISP in IPv4 environment for unicast routing. You know that LISP is the abbreviation of the Locator Identifier Separation Protocol. Okay, let me to explain this scenario, and after that I will show you how you can configure this scenario. This is an interesting scenario. Okay, let's get started with this scenario. In this scenario, as you can see, we have three LISP sites. This is the first LISP site, this is the second LISP site, and this is the third LISP site. LISP site, for example, 1. This is the LISP site 1, the first LISP site. And as you can see, in LISP site 1, we have one XTR. XTR, you know that in LISP terminology, XTR or XTR, okay, is the ITR, ingress tunnel router, and also ETR, egress tunnel router, okay. XTR means this router can be ITR and also ETR. The function of this router is ITR means ingress, okay, tunnel router, and also simultaneously it's an egress tunnel router, okay. We call it briefly XTR. Instead of using ITR, also ETR, I'm using the XTR. It's so easy. Okay, LISP site 1 now is connected to the XTR1, and also we have LISP site 2 connected to the XTR2 as an edge router, and also LISP site 3 connected to the XTR3. This is our scenario, and you know that in XTR1, okay, here in the site of XTR1 we have one range of IP address. In site of XTR2 we have another range of IP address, and finally in the site of XTR3 we have another range of IP address, 192.168x0/24. And also in this scenario, we have one router, the router 4, that is the MS, means mapping server, and also MR means mapping resolver. Let me to show you here. This is the, for example, XTR1 is our R1, and XTR2 R2, XTR3 R3, and then mapping server, or for example MS is the router 4. This is the router 4. Let me to show you. And after that we have mapping resolver, and this mapping resolver also is router 4 MS. Let me to show you here. MS is abbreviation of the mapping server, and also MR is abbreviation of the mapping resolver. Okay, very good. This is our scenario. XTR1, XTR2, XTR3 are edge of our LISP sites, and also we have one MS and also MR. In this scenario, MS and MR are reside in the one router, in the same router, the router 4. Okay, very good. How LISP is working? You know that by default, when starting the scenario, XTR1, XTR2, and XTR3, you know that XTR means ITR and also ETR. First, the function of ETR is working, okay? ETR should register with map register message, okay? It's EID prefixes, okay, to the, for example, MS as a mapping server, okay. For example, here EID is EID in the content of the map register. We have EID prefix. Let me to show you. For example, ETR1 is XTR1, okay, should advertise with the map register message 192.168.10/24 to the MS, and this means that I have connectivity to these networks. And with this EID, this is the EID, okay? Endpoint identifier prefix, or for example, EID. And after that, it should advertise its routing locator to the MS. RLOC is the abbreviation of the routing locator, okay? Routing locator is an IP address that we define, for example, V on the R1, for example, a loopback IP address. Routing locator in this scenario is a loopback IP address on the XTRs. For example, in R1, I configured quad 1/32. In R2, I configured quad 2/32. And in R3, I configured quad 3/32 as a route reflector. Quad 1/32, okay, now should advertise to the MS as a route locator. This is the EID, this is the map register from the ETR1 to the MS. After MS received this update, this map register message, MS should send back map notify message to the, for example, ETR1, and this means that I receive your map register. Very good. After that, ETR2 also should send its update with its EIDs with the RLOCs to the MS. Let me to show you. ETR2 should advertise 192.168.20 with the routing locator quad 2/32. And after that, finally, ETR3 should advertise this EID 192.168.30/24 with the routing locator of quad 3 to the MS. And this is the first step in the LISP process. Now, MS has a table. This table has two important parts. First, EID, which EID reachable with from which routing locator. In MS, let me to show you now. In MS, we have this table, map table, for example. Okay, let me to show you. In this map table, we have EIDs and also routing locator. Let me to complete this table. 192.168.10/24 received from the RLOC quad 1 or can reachable with the quad 1, and also 192.168.20/24 reachable from quad 2, and also 192.168.30/24 reachable with the quad 3. This is the first step, okay? After that, when one ITR needs to send the traffic to the, for example, one of these networks, it should request from the map resolver the routing locator. Let me to show you. Assume that, for example, we have a traffic in R1 received from VPC1. From VPC1, we have a traffic destined to the 192.168.210. Okay, and this traffic now should receive with the R1. Okay, this is the R1. R1 is our ITR and also ETR, but here R1's ITR role should working. Okay, and no, R1 receives the traffic for 192.168.210. R1 first searches its routing table and it can't find any route for this network. Why? Because you know that in the LISP terminology, in the LISP process, only in the underlay we have in the routing locator space here at the top of the scenario, only we have the routing locators and also the links addresses between them. We don't have any information about the detail of the LISP site, about any subnets reside in the LISP site. Because of that, R1 doesn't know the 192.168.20/24. Because of that, R1 as an ITR should send a map request, okay, to the, for example, MR. MR is our map resolver. MR receives this map request and should send this map request to the MS as a mapping server. Map resolver receives the request and send this request to the map server. Okay, map server or MS should search its table and find